So when b is bigger than 1, we know we have a horizontal compression. So in this case above, we had b equals 2, the horizontal compression by 2, or 1/2. And when b is less than 1, we end up with a horizontal expansion along the theta axis. So here we have the b value less than 1. So that's going to affect our period by horizontally expanding this. So when we horizontally expand this, the period ends up being, the formula is 2 pi over the b value, and that works out to be a horizontal expansion of times 2, or a period of 4 pi. So what I end up with then is our end position here is at 4 pi. And we can take each coordinate and horizontally expand it. But again, I think it's easier if we start thinking about this in terms of quadrants. So I'm going to find the midpoint here. Okay, find a midpoint, I can do 0 plus 4, start plus end, divide by 2 gives us 2 pi. And then I can, again, divide that into the quadrants here. Find the midpoint between the middle and the start. Middle and the end gives us quadrants 3 and 4. So there are 4 quadrants. So what ends up happening then is, we know that in the first quadrant, it's going to go from the max down to 0, like that. In the next quadrant, it's going to go down to the minimum point. And then I draw in that quadrant. It's going to then go back up to 0, so the next quadrant goes back up to 0, and then it ends at 1. So in the fourth quadrant, it goes back up to 1. And we can see that everything's been horizontally expanded by 2. And this is doing it slightly different than taking each coordinate and horizontally expanding along the x-axis. We divide it into the 4 quadrants and use the 4-part symmetry of the circle. In this next example, this is the b value is less than 1 again. So the period is going to be a horizontal expansion, in this case, by 3. So we end up with a period of 6 pi. So then I've got my original sine theta graph, starting at 0, going up to 1 to 0, back down and back up. Now I'm going to stretch this. So I'm just going to, again, mark my end position, and I'm going to divide it into the quadrants. So halfway, I draw it in. There's my boundary for the halfway, and then in between 3 and 6, I'm going to do 3 plus 6 divided by 2 is 4.5, or 9 over 2. And that's going to give me the boundary for quadrants 3 and 4. So this is, I'm going to zoom in here, this is going to be 9 pi over 2. And then we can do the same thing between 3 and 0. 3 plus 0 divided by 2 gives me the boundary, the quadrant boundary at 3 pi over 2. So now I've divided up into its 4 quadrants, and again, I can just use the quadrant symmetry to draw this graph. So the first quadrant, I know it starts at 0, goes up to 1, back down to 0, down to -1, and back up to 0. These are the 5 coordinates I want to keep track of when I'm sketching my graphs, and they all relate to the quadrants. So I have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And this then shows that I have a horizontal expansion by 3 when I compare it to the original sine graph in light blue.